Okay, hi everybody. So today I'm going to be going through 11 through 20 of the purple test in the BC review binder. Okay, so here we go. Okay, so the first one, the Maclaurin series for 1 over 1 minus x is given by this summation. Which of the following power series is an expansion for x squared all over 1 minus x squared? So comparing and contrasting the two here, you notice there's two different differences. You have x squared and there's an x, and then you have an x squared and a 1 up top here. So we have two different things that are going on. The first one is we're going to switch out the x squared, sorry, the x for an x squared. So all we're going to do is everywhere in here there's an x, we're going to place an x squared. Okay, so in doing so, I'm going to have 1 all over 1 minus x squared is equal to the summation as n goes from 0 to infinity of x squared to the power of n, which gives you x to the 2n power. Okay, so the next thing I need to do is I need to have the x squared in here. Like I said before, this is going to be substitution. Now this, all you have to do is just simply multiply both sides by x squared here to get that. So that's what I'm going to do. So in doing so, I have x squared all over 1 minus x squared is equal to x squared times the summation as n goes from 0 to infinity of x to the 2n plus 2. Oops, I'm sorry. I skipped ahead one step. I'm going to just cross that off. Just 2n. Okay. Now, since this x has nothing to do with the n's, I'm going to go ahead and bring it inside. So this is going to be the summation as n goes from 0 to infinity of x to the 2n plus 2. See, there's the plus 2. Okay, now I just have to plug in some values. So plug in 0, that's going to go away, and I'm just left with x squared. So you notice the only one I can get rid of is that one up there. Okay, then plug in 1. So plug in 1, you're going to have 2 plus 2, which gives you 4. So this is plus x to the power 4. The only one that matches up there is D. Okay, and away we go. Okay, so the next one. The rate of change of volume V of water in a tank with respect to time. So real quick, rate of change, that's the derivative. So the rate of change of volume with respect to time, that is dV dt. So right away, these are wrong because the answer has to be dV dt. Okay, is directly proportional to. Now, what exactly does that mean? Okay, if I stated that y is directly proportional to x, that means y is equal to some constant value times x. Okay, so if I had star is directly proportional to um, triangle, it'd be k times triangle. Okay, that's all direct proportional means. Okay, if I happen to say inversely proportional, because that does come up, then it's y is equal to k all over x. So it's divided by, but once you have a constant there. So if star is inversely proportional to triangle, then you have star is equal to k all over triangle. Okay, anyway, enough with that. So the rate of change of volume, dV dt, is directly proportional to the square root of volume. It's right here. The rate of change of the volume with respect to time is directly proportional to the square root of volume. So the answer is E here. Okay, next page. Okay, number 13. So the focus isn't working super great on this camera. Hopefully that works better. Okay, so the graph of a function f is shown above. At which value x is f continuous but not differentiable? So A, B, C, D, or E. Okay, so A, is it continuous at A? Yes, I can draw it without ever picking up my pencil or pen. Is it differentiable? No, because it's a sharp corner, so the answer is A. Okay, once again, not differentiable makes reference to uh, sharp turns and our cusps and vertical tangent lines. Okay, so vertical asymptotes. Okay, so the answer is A. Okay, next page. So shown above is a slope field for which of the following differential equations. So remember slope fields, each one of these points gives you what the slope would be at that point. So for example, 1, 1, maybe it's like right in here. It looks like it might have a slope of about 1. Okay, so I'm going to give you some unnecessary information, but I'm going to walk you through what my thought process is. Okay, so the first thing I always do is I say, okay, well, what will make this thing equal to 0? So if you notice, each one of these equations, the numerator, the only way this can make each one of these equal to 0 is when the numerator is equal to 0. So x equals 0, x is equal to 0, so all the way through. So x equal to 0 is right here. As you can see, the slope is equal to 0. Well, that doesn't really help us much, but once again, it's a thought process. The next thing I do is I say, okay, where is it undefined? So it's undefined when y is equal to 0, so all along here, but once again, that doesn't help us because there's really nothing different. Okay, so the next thing I do then is I go to the quadrants and I say, okay, are there some patterns with the quadrants? So if you notice here in the first quadrant, all the slopes are positive. Everything is going up from left to right. So in other words, when x equals is positive and y is positive, the slope should be positive. So if I plug a positive over a positive here, do I get a positive? Yep, yep, all the way through. It doesn't help us much, but once again, the thought process. Okay, so then let's go to the fourth quadrant. If you notice the fourth quadrant, everything is positive as well. And in the fourth quadrant, x is greater than 0, but y is less than 0. So the x is positive and the y is negative. So which one of these, when I plug it into these equations, will give me a positive value? Here, it's going to be positive or negative, but I need the slope to be positive, so that one won't work. Okay, here when you plug in a positive, you get a positive. When you plug in a negative, you get a positive because you're squaring it. So this one still could work. Positive over a negative, that won't work. Positive over negative, that one won't work. And here, when you plug in a positive, you're going to get a positive. And you plug in a negative, you're going to get a positive out because you're squaring it. So positive or positive because you're positive, it could be E as well. Okay, so let's go to another quadrant. Let's go to the third quadrant. So notice here, the slope is negative, and I know that x is less than 0 and y is less than 0 in the third quadrant. So which one of these, when I plug in a negative and a negative, will give me a negative? If I plug in a negative and negative here, I'm going to get positive over positive, which is positive. That's not what I want, so that one's gone. Over here, if I plug in a negative, I'm going to get a negative. Negative, I'm going to get a positive. Negative by a positive is a negative, so my answer is E. Okay, next question. Okay, 15. So the length of a curve from x equal to 1 to x equals 4 is given by the integral from 1 to 4 of the square root of 1 plus 9x to the fourth dx. If the curve contains the point 1, 6, which of the following could be an equation of the curve? So you should see this and you should recognize what this is. This is the formula for the length of the curve of a Cartesian equation. A Cartesian equation is y is equal to f of x. So the formula, which you need to know, you need to have this memorized, is the distance is equal to, the square root from a to b, the integral from a to b of the square root of 1 plus f prime of x squared dx. Okay, that's the formula, and once again, you need to have that memorized. Okay, so let's just compare and contrast. So if you look at this and you look at that, we know what the a and b are, we know 1 is 1, but here's the key component here. The derivative, when you square it, is equal to that, 9x to the fourth. So I have the derivative, when it's squared, is equal to 9x to the fourth. That means that the derivative should be equal to 3x squared. So all I have to do is come over here and decide which one of these, when I take the derivative, will give me 3x squared. Well, if you wanted to, you could integrate this, and you know you have f of x is equal to x cubed over 3, so I have x cubed, and then plus some constant value c. So the only one that has an x cubed to it is going to be b or c. And that's where this comes into play as far as narrowing it down. It has to pass through the point 1, 6. So which one here, when I plug in 1, am I going to get out 6? Clearly the answer is B. Okay, number 16. So if the line to the graph of the function f at the point 1, 7 passes through the point -2, -2, then f prime of 1 is what? Okay, so let's talk about this. We have the line tangent to the graph of f. You know you can represent that in the form of y minus y1 is equal to the slope times x minus x1. Okay, that's just slope, or that's just the equation of a line. Um, Now it's tangent at that point, so I know that point then will work in here. So I know I have y minus 7 is equal to m times x minus 1. The only thing now I need is the slope. Well, actually, that's what the question's stating, right? So I don't really know what it is, but what I can do is I can just simply substitute it in. So I have y minus 7 is equal to f prime of 1 times x minus 1. Now, this line, so say the curve, and I don't know what this graph looks like, but say the curve looks like this, and this is the point right here, which is 1, 7. Now, when you draw on this tangent line, it's going to look like this. You know that this line, by this statement, is going to go through -2, -2. What that means is that the point -2, -2 should work in that equation. So let's plug it in. So I have -2 minus 7 is equal to f prime of 1 times -2 minus 1. And then this is really neat because this allows us, because what we're trying to solve for, we're trying to solve for this. Everything else is just a number. So I have -9 is equal to the derivative evaluated at 1 of times -3 dividing through. The derivative evaluated at 1 is equal to 3. So the answer is C. Okay, next question. Okay, so number 17. A curve C is defined by the parametric equations x equal to t squared minus 4t plus 1 and y is equal to t cubed. Which of the following equations is the line tangent to the curve of C at the point -3a? So once again, and this is not what the curve looks like, but say for example the curve looked like this. This right here would be the point -3, 8, and then you have the tangent line. So what are the two things you need to know in order to come up with the equation of tangent line? Okay, you know it's a point and a slope. So I can put this in, so we need to figure out the point is. Well, we already have it. All I need to do now is figure out what the slope is. Now slope is always going to be dy over dx. Okay, the problem here is this is in parametric, where your x is in terms of t and your y is in terms of t. Well, if you recall, that means that this is just dy dt all over dx dt. So let's take the derivative of y, derivative of x, and just plug it in. So the derivative of y up here is, let's see, where can I go with this? Let me go right up here. I have dy dt is equal to 3t squared. And then I have dx dt is equal to 2t minus 4. Okay, so plugging this in, I have 3t squared all over 2t minus 4. And then, well, I just need to figure out what the t value is, which I don't know. So I probably have to figure out a way to come up with it. So let's go back to the equations that actually have t's in them. So I know that this is a parametric and it's going to pass through this point. That means when I plug in some value t for t here, I'm going to get out 8. So I have 8 is equal to t cubed. T is equal to 2. So t is going to be equal to 2 at this point. So I have dy dx then is equal to 3 times 2 squared over 2 times 2 minus 4, which is equal to 3 times 4, 12, all over 0. What does that mean? We're dividing by 0, which means our slope is undefined, which means our line is actually vertical. Well, you should know that equations of vertical lines are just x is equal to, because the x value does not change. So if I go back up to this point, x is equal to -3, so go here, the answer is A. Okay, next question. Okay, so the graph of the function f is shown in the figure above, and it has horizontal tangents at that and that. That's just saying the slope of the tangent line is equal to 0 there and there. G of x is equal to this equation. What is the value for g prime of 3? Okay, so I need g prime. So I know I have to go over here and take the derivative. So I know I have to use the first fundamental theorem of calculus. Sorry, second fundamental theorem of calculus. So I have g prime of x is equal to, you plug it in, f of 2x times 2 minus f of 0 times 0. So this is equal to f of, so I have g prime of 3 is equal to f of 6 times 2 minus, well, that's just 0. Now what is f of 6? This is graph of f of 6. F of 6 turns out to be, so 1, 2, 3, 4, 5, 6. And I go over here, and it is going to be negative 1. So I have negative 1 times 2, which gives you negative 2. So the answer here is going to be C. Okay, two more. 19. So the curve of the slope y is equal to 2x plus 3 at each point xy on the curve. Or sorry, it has a slope of this. Which of the following is an equation for the curve if it passes through this point? So if you're given the derivative, you got to go back to the original problem. You just have to integrate this. So the integral of 2x plus 3 is going to be equal to x squared plus 3x plus c. I just need to figure out what c is. You know, it passes through the point 1, 2. So 2 is equal to 1 plus 3 plus c. 2 is equal to 4 plus c. C is equal to negative 2. So the equation becomes y is equal to x squared plus 3x minus 2. So D is your answer. Okay, last one. Okay, so a function f has a Maclaurin series given by x to the fourth over 2 factorial, x to the fifth over 3 factorial, and so on. Which of the following is an expression for f of x? This one's tricky. So you have to be able to look at this and kind of recognize what it kind of looks like, and then we have to manipulate it. The first thing that jumps out to me is that there's no plus or minuses. So it doesn't really have any relationship to maybe cosine or sine. I mean, possibly, I guess we could manipulate it, but it's probably not going to be that. My first thing is like it maybe is e to the x, because e to the x is all positives. The only difference is this should be an x squared, that should be an x cubed, x to the fourth, and so on. But you notice this has too many x's, because it should be x squared, but it's x to the fourth, and so do all the rest of them. So what I'm going to do is I'm going to factor out an x squared. And in doing so, I have x squared all over 2 factorial plus x cubed all over 3 factorial plus x to the fourth all over 4 factorial plus and so on, all the way up to x to the n plus 1 all over n plus 1 factorial. Okay, it's really close now to e to the x, but it's not quite. It's missing a few pieces. So what I'm going to do is I'm going to play a trick here, and I'm going to add on what I need to change it into an e to the x. So what is it missing? It's missing an 1, and it's missing an x squared. So I'm just going to simply add it on. So I have 1 plus x squared all over 2 factorial plus x cubed all over 3 factorial, so on. But now I just can't add that on. It's going to totally mess up the value of this. So all I'm going to do is I'm going to take it away now. So if I added a 1, I need to subtract a 1. And since I added an x, I'm going to subtract an x. All I did is I simply just added 0 there. Okay? Now what is all of this equal to? That is e to the x. So this gives me x squared times e to the x minus 1 minus x. And when I distribute, I have x squared e to the x minus x squared minus x cubed. And so my answer is D. Okay, so there we are. Hopefully you guys understood it, and I will see you later. Thank you.